Expect the unexpected. What do I mean with that? Did you know that 2017 a comet named 1L Oumuamua passed or went through our solar system with a different or a distance, better said, not difference, of around 24 million kilometers from Earth. That's around 60 times as much as Earth and as the distance from Earth to the moon. Okay? And this comet, many people talked about this, okay? And I always wanted to do a video about it, always. I think everybody, as soon as they see the picture, knows about this comet. It's like tin shaped, like a sword in a way. It's strange. It's kind of shaped like this weird thin but long rock. I don't know, but yeah, its absolute brightness, by the way, would be 22.08, radius 200 meters. Perihel of our solar system was the 9th of September of 2017. The Robert Warwick found the comet on 19th of October of 2017 in Haleakala Observatorium. Okay, so this is a very interesting theory, or just theories. Like, everybody did theories on that. We all know what happened to this comet and how it went throughout our solar system and why it seems impossible. Later in this video, why it seems impossible, by the way. And there are many theories in the internet, in Reddit, in Twitter, in YouTube, in Instagram, in Facebook, in WhatsApp, in wherever. Everywhere I go, I find this asteroid, Oumuamua. Okay? And this asteroid right here is something very special. On 14th of October, so a few days before it actually got found, it had its least distance to Earth, but still 24 kilometers is still a lot, okay? But today we want to talk about Oumuamua, and if it is an alien technology, we don't know if it is from aliens or if it is a comet, but I will say to you why we have the theory. And also, even Harvard University professors are sure that this is an alien object, okay? That this is an alien spacecraft and not a comet, okay? Oumuamua. The Voyager spacecraft from another civilization? Question mark. That's something what we're gonna solve today, or what I'm gonna explain to you if it is or if it's not. And I can already tell you guys that the results will be shockingly for most of you guys. So just listen me up while I read something right after. So have fun with the article I'm gonna read, or the own wrote article. This is brand new, by the way. We found this out brand new, okay? And so before I'm going and read the article, I wanna ask a question. Do you guys think that this asteroid right here, or not asteroid, why am I always saying asteroid, comet right here, is actually a alien spacecraft, or if it is just a normal, by nature did comet, okay? My theory, I don't think that it's something normal, because facts are speaking against it. There are facts that are speaking for it, but the most facts can be actually reversed, and so that's why I think that it's actually not a normal natural object. But yeah, that's already it for me, and now I'm gonna read something for you guys, so enjoy it. Aliens or a chunk of solid hydrogen? Which idea makes less sense? Okay, now we're gonna like put this together what we talked till now, and now we're gonna talk about what would make more sense, like what would be more possible, or what would be just more intelligent to like think, or maybe do. So yeah, whatever. So Oumuamua, sorry, it's a pretty hard name to pronounce, a mysterious interstellar object that crashed through our solar system 2 years ago. Or no, now it's even more. Wait, it's 2000. Oh, damn. Now it's already more. 4 years ago already. Damn. Okay, we can say 3 years and already over 3 years. No, isn't it? I'm lost. But yeah, 4 years in October, so we can say around 3 years and a few months. I think 3 years and 5 months or 4 months, something around that. I hope I'm right. Yeah, but something around that. So just remember October 2017 might in fact be alien technology. That's because an alternative non-alien explanation might be fatally flawed, as a new study argues. So this is a brand new study that we know about, okay? So this is something brand new. So listen up right now. This is gonna be very interesting and very informative. So now it's a time to listen. But most scientists think the idea that we spotted alien technology in our solar system is a long shot. In 2018, our solar system ran into an object lost in interstellar space. No, it's actually 2017. Yeah, 2017, sorry. This is wrong what I wrote. The object dubbed Oumuamua seemed to be long and thin, cigar-shaped, and tumbling end over end. Then close observation showed it was accelerating, as if someone were pushing on it. Scientists still aren't sure why. One explanation: the object was propelled by an alien machine, such as a light sail, a wide millimeter thin machine that accelerates as it's pushed by solar radiation. The main proponent for this argument was A.V. Loeb, a Harvard University astrophysics physicist. Sorry. So most scientists, however, think Oumuamua wonky acceleration was likely due to a natural phenomenon. In June, a research team proposed, so June of last year, proposed that solid hydrogen was blasting invisibly off the interstellar object surface and causing it to speed up. Now, in a new paper published on Monday, August 17th of last year, in the astrophysical journal Letters, Loeb and team Huang, and astrophysics at the Korea Astronomy and Space Science Institute, argued that the hydrogen hypothesis couldn't work in the real world, which would mean that there is still hope that our neck of space was once visited by advanced aliens, and that we actually spotted their presence at the time. It's a problem with Oumuamua. It moved like a comet, but didn't have the classic coma or tail of a comet, said astrophysics Daryl Seligman, an author of the solid hydrogen hypothesis, who is starting a postdoctoral fellowship in astrophysics at the University of Chicago. Oumuamua was the first object ever seen flying into our solar system and back out again. That's opposed to most solar system objects that turn in circles around the sun, never leaving the celestial neighborhood. With its journey and the fact it was accelerating suggested Oumuamua, which is estimated to be about 1,300 to 2,600 feet or 400 to 800 meters long, was a comet, and yet there was no coma or outgassing detected coming from this object, Seligman said. Normally, comets come from regions more distant from the sun than asteroids, and ice on their surface turns straight into gas as they approach the sun. That's why it's pretty rare that or more common that a asteroid would hit Earth instead of a comet. But if a comet would hit Earth, it would be way more devastating because most comets are bigger than asteroids, but it's not always the case, okay? There can also be huge asteroids, especially in the Mars belt, in the outer interstellar space belt and everything. There are huge comets. It can be comets that are, I don't know, 1,000 kilometers. Its radius 1,000 kilometers. That's huge. That would wipe out all life on Earth. All, nothing would sustain there. Nothing. As a comparison, the asteroid that hit actually the dinosaurs, the Chicxulub crater, it was only 11 kilometers. That's nothing if you compare it to a 1,000 kilometer object. That's nothing, okay? So, yeah, leaving behind a trail of gas or what we see as beautiful calm tail, Seligman said. That outgassing changes how the comet moves through space, he said. It's a bit like a very slow rocket engine. The sun strikes the comet, the warmest part of the comet bursts with gas, and that gas flowing away from the comet sends it tumbling faster and faster away from the sun. In a paper published on June 9th last year in the Astrophysical Journal, Leda Seligman and Yale Astrophysics Geology Laughlin proposed that the object was a comet made up partly or entirely of molecular hydrogen lightweight molecules composed of two hydrogen atoms, or H2, in chemistry, how you would call it. So H2. H2 gas freezes into a puffy low density solid only when it's very cold, minus 434.45 degrees Fahrenheit, or minus 259.14 degrees Celsius, or just 14.01 degrees above absolute zero. So that's pretty cold, yeah? That's very cold, near absolute zero. Okay. In Earth's atmosphere, researchers have already proposed existence of hydrogen icebergs out in the very cold reaches of space. Laughlin and Seligman wrote in a study, and outgassing hydrogen wouldn't be visible from Earth, meaning it wouldn't leave behind a visible comet tail. The numbers worked out neatly, while a few other substances like selenium could potentially explain the coma-free acceleration, hydrogen was the best match for the data. But in their new paper, Huang and Loeb respond to this idea and argue that the hydrogen iceberg explanation has a basic problem. Comets form when icy grains of dust bump into each other in space and form clumps. And then those clumps attract more dust and other clumps. And comets are like snowmen. They survive only as long as they don't melt. So this is pretty interesting. If they come too close to the sun, then it should melt in a way, because of course they are in the outer side of our solar system, in near Pluto, or even farther than Pluto. Yeah, way farther than Pluto. Maybe near some other dwarf planets, because we have some more. But it's very unlikely. I think they're more farther away from it. So this is also a very interesting topic. If they come too close, shouldn't it melt? So that's basically the problem. Why it cannot really be a comet? I don't know. It's really hard to say if it's a alien Voyager or what that is. The thickness that helps form comets is similar to the thickness of ice cubes coming straight out of a cold freezer. Leave an ice cube on the encounter for a minute or two, let its surface warm up a bit, and it won't feel sticky anymore. A thin film or of liquid water on its surface makes it slippery. Huang and Loeb argued that even starlight in its coldest part of space would warm up small chunks of solid hydrogens before they could clump together and form a comet of Oumuamua's large scale. And more importantly, the trek from the nearest giant molecular cloud, a dusty, gassy region of space where hydrogen icebergs are thought to form, is far too long. A hydrogen iceberg traveling hundreds of millions of years through interstellar space would have fallen apart, cooked by starlight. So that's actually a proof why it must be something else. It's not 100% yet, but for me, it's a pretty big and good argument. Seligman said that Loeb's analysis was correct and no hydrogen comet would survive such a long trip. Hydrogen icebergs don't live that long in the galaxy, he said. And you definitely don't have time to get all the way from the nearest giant molecular cloud. So the theory only works if Oumuamua is just 40 million years old, he said. Over that time frame, over that time frame, I don't know, over the time frame it would just not be here. Okay? So it's really interesting. Okay? What do you guys think? Yeah. So let's move on. Over the time frame, outgassing could have molded the comet's oblong shape without destroying it entirely. So that's also something about it. He pointed to a paper published in April last year in the Astronomical Journal, which proposed a number of nearby origins points from Oumuamua. The paper's authors didn't nail down the comet's home entirely, which would be impossible to say. Oumuamua was hardly moving when it arrived in our sun's gravity well, which makes tracking the comet through space tricky. But the researchers looked at what else passed through the Milky Way neighborhood that our sun is now passing through in the recent cosmic history. They landed on two groups of young stars, the Carina and Columbia moving groups, said Tim Hallett, a graduate student and astrophysics at McGill University in Montreal and lead author of paper published in April. They all formed around 30 to 45 million years ago in a cloud of gas that then dispersed. That small dissipated cloud of molecular gas with just a few young stars is one where hydrogen icebergs might form, Hallett said. There are many processes that can eject Oumuamua's type object form young stars in moving groups, like gravitational nudges between stars in the group planet formation, or a Seligman and Laughlin 2020 argue. The molecular clouds that created the stars in the first place, Hallett told Life Science. There are many processes that can eject Oumuamua's type objects. I already read that, sorry. But yeah, now a quick real talk. So now again, that argument that why it can be a not a alien Voyager, and this also seems a very good strike back. But it's still strange in my opinion. I don't really know. Like there are good arguments on both sides. Now the question is, what side should you believe, or which one would you rather join, if you know what I mean? All three papers fit nearly together if you assume Oumuamua was a hydrogen iceberg that originated in Carina or Columba, Hallett added, so the stars. Seligman and Laughlin's idea could work here because H2 objects should have a short lifetime in the galaxy, as Loeb correctly concludes, and an origin in Carina and Columbia would make it young enough to survive its journey, he said. Loeb, however, disagrees. Shortening the distance that H2 iceberg needs to travel does not solve problems we outline in our paper, because the H2 iceberg would have formed when its parent planetary system formed billions of years ago, and in those eons the iceberg would have evaporated, he told Life Science in an email. So now again a strike back. So it's a argument against argument against argument. So it's always a strike back. Always there's always something coming. Loeb also said that hydrogen icebergs are expected to come from giant molecular clouds, not parts of space like Carina or Columbus. So there we go. That means it needs to be older than the 30 or 45 million years. If it's a comet, then it would have evaporated. If it, then it would make no sense. If it's older, then it would already evaporated. The comet. That's strange. And he reiterated that no hydrogen iceberg could survive the trek from the nearest giant molecular cloud. So there we go. Again, a strike back. Ask if there is a clear leading candidate explanation of Oumuamua's acceleration. Loeb referred Life Science to a not yet released book he authored called Extraterrestrial, the first sign of intelligent life beyond Earth, due to publication in January of 2021. So today's video is a very long one, 24 minutes. I'm just talking today with no cuts, maybe you notice it. But yeah, I just wanted to talk with y'all a little bit about this topic, and this is really, really, really interesting. And what do you guys think? Alien? Space Voyager or spacecraft, spaceship, we don't know? Or actually maybe something else, a comet, asteroid, meteoroid, but yeah, meteoroid, it would be too small. But yeah, what do you guys think in the end? I think it's nothing natural. If it would be something natural, then it couldn't be formed in one of these star systems that we talked about earlier. But if it couldn't, then it would already like physically it would already be evaporated if it is more than 40 million years old. That just cannot be possible. Like the star systems Carina or Columba, if it's not from there, and they literally like a little bit prove that it's not from there because there are no molecular clouds there, where else should it be? And since that's in a time span of 30 to 45 million years, then it needs to be even older than that to actually form itself. And over that, how can it survive that long without evaporating? That's physically and scientifically, sorry, and or astronomically just not possible. It's just not possible. So I think it's something very special, but not especially a comet. But we will find it out, I hope, very, very soon. If there is something new about this comet right here, then I will keep you guys up to date. So just check it out. I will keep you guys up to date, okay? With everything about the Oumuamua, okay? I hope this video was pretty interesting. I think it was very interesting. Always wanted to do a video about this topic. And yeah, thank you for listening. I'll be with you in the next video. And great. Bye.